Using a circuit, like shows by the figure, a set of collector characteristic curve can be generated that show how the collector current IC varies with the collector to emitter voltage VCE for specified values of the base current IB. Notice that in the circuit diagram that both VBB and VCC are variable source of the voltage. VBB will control the base current IB. VCC is to control the collector current IC. VBB is set to produce a certain value of IB and the VCC is 0. During this condition, both the base emitter junction and the base collector junction are forward biased. Collector current is 0 and transistor in saturation region. When VCC increase, VCE increase as the collector current increase. This is indicated by the characteristic curve between point B to the C. IC increase as VCC increase, so the transistor mode in the active or linear region. When VCE reach a sufficiently high voltage, the reverse bias base collector junction goes into breakdown and the collector current increase rapidly as indicated by the curve to the right of point C. Transistor is never be operated in this region. There are three regions of operation for the BJT. The first one is the saturation region, cut-off region for the IB less than 0, and the active region. A family of collector characteristic curve is produced when IC versus VCE is plotted for several values of the IB as given in the figure. When the IB is equal to 0, the transistor is in the cut-off region, although there is a very small collector leakage current indicated. Cut-off is the non-conducting state of the transistor. This graph shows the various value of the IB or the base current. From the family curve, we can determine the value of beta. Beta is known as the current gain, which is equal to the IC divided by the IB. For example, at this point, we take the value of IC is 6 milliampere and the IB is 40 milliampere. So we divide both values, so we get the beta is equal to 150. Another example is for the IC equal to 14 milliampere and the IB is 100 milliampere. We get the beta is 150. We get the beta is 140. The gain is called beta DC or HFE, and we know that the IC equal to beta IB. The beta for a transistor is not always constant. There are also maximum power rating to be considered, and the datasheet provides information on these characteristics.